Good day to everyone. So today I would like to present some use cases using Akoma Ntoso standards to improve the application of artificial intelligence inside of the Parliament. Before to jump to the use cases, I wanted to recall some principles. First of all, we are now assisting a very improvement of artificial intelligence tools, especially in the legislative domain inside of the parliament. And we can divide this application in four main families. Application to support legislative offices, and to assist the legal drafters or to check the quality or to help the linguistic translation. Another important family want to assist the member of the parliament and to exactly help to explain the complexity of the legislative network of norms and to help a simplification of this complexity. Another family aims to help the democratic debates. So creating an executive summary of the law, to explain the policy, to check and monitor the policy. And finally, we found artificial intelligence tools to improve the relationship between the parliaments and the citizen, like the chatbot or conversational queries or smart search engine. In this scenario, we have now also some reports. One valuable report was made by Fotis Fitlisi of the Hellenic Parliament and in conjunction with the European Commission. And this is a very important survey where you can find that artificial intelligence is now coming inside of a parliament, but very slowly. However, other important digitalization tools are now present, and they are a very important starting point for proceeding to apply artificial intelligence. So the message is we can't jump immediately to artificial intelligence without previous steps of digitalization and good quality of the data and the documents. Obviously, to introduce the artificial intelligence in Parliament implies to have a very important issues and critical point. We need to check the provenance of the legal sources, to have and guarantee the sovereignty of the platform, especially if there are third parties and market vendors, to guarantee explicability, transparency, accountability of the results, avoid bias and discrimination, and balance the risk and the benefit in order to maintain the autonomy of the legislative process and the member of the parliaments. Another very important issue is to maintain the separation of the powers, because very frequently artificial intelligence tools start inside of the parliament but move fastly in the government level, and so the distinction between government execution and legislation and legislative power is not so evident. And this is a very important part of the design of a system of AI inside of the legislative process. And we found, in any case, some critical issue to pay attention when we use artificial intelligence like machine learning or large language model in the legal domain. First of all, many of you probably knows very well that a large language model are based on the probability to find a word in such given sequence. So the structure of the document is neglected totally. We divide with the LLM the document in chunk, and we lose the relationship between the valuable part of the discourse of the structure of the document. Secondly, we lose some metadata very relevant in the legal domain, like jurisdiction or the temporal parameters, the entering force, the time of application. and also the meaning of the normative references, because the normative references is a shortcut for making a citation to another text, but for the LLM or machine learning is just a sequence of words. And so the Article 3 and the Article 13 are mostly the same for these kind of tools. Another important point that we need to pay attention is definitely the time of the legislation, the temporal parameters. I mentioned before, when the law enters in force is very relevant, especially for the judge, but also for the member of the parliament, in order to understand the valid version of the law, and also the provenance in case of citation of authoritative sources. So these kind of issues are mostly under the attention and the light of many scholars. As you can find many books that provide an analysis, very balanced, no panic about that, but we need definitely to tackle this kind of critical issues. For do so, my research team use so-called hybrid AI. So what is a hybrid AI is the combination of many technologies together, and in order to mitigate the previous critical issue, we can use as a common part of this integration the standard based on XML called Akoma Ntoso. So we create a pillar in the middle based on a standard XML annotated by legal people with valuable legal knowledge coming from authoritative bodies. And around of these, we can inject artificial intelligence tools or data analytics or ontologies in order to mitigate the critical issue presented before. My group is now also working in this domain called the neurosymbolic, that integrate a large language model based on a probabilistic approach, a stochastic approach, with the semantic approach. So this is a very a new application, and we take benefit from the semantic in order to integrate the probabilistic model with the meaning coming from the legal experts. As I said, in any case, in the middle of this complex architecture, we find Akoma Ntoso or legal XML, that is a OASIS standard. And in such a way, we can create, first of all, a valuable data set annotated by legal human being experts. And so the semantic is transmitted to the machine, and also the structure of the document is well understandable by LLM and also machine learning. Secondly, using Akoma Ntoso, it is possible to ask at the end the explanation of the result produced by artificial intelligence, because in the back there is not only plain text, but a network of references, meaningful, and also an annotation coming from legal people. Now I would like to present 3 use cases based on this methodology, hybrid AI with the pillar inside of Akoma Ntoso. These 3 use cases are being developing with the contribution of the European Commission and the Chamber of Deputies of Italy. And in the last July, I had the honor to receive the award from the President of the Chamber of Deputies and the Vice President of the Chamber of Deputies. So I now present 3 use cases. The first use case is focused on to assist the legal drafter and the offices, but also the member of the parliament, in case to retrieve relevant legislative sources by heterogeneous databases linked with the bill. So suppose you are drafting a bill, you need first of all to retrieve all the relevant information coming from European legislation, constitutional court, or national law, in order to not to create conflict, or in case to be conscious to have some conflict, and to prepare a legal analysis ex ante, so-called, for presenting the bill in the legislative process. The second use case is focused on another task to monitor the policy. So you suppose that the parliament or the government has in mind a policy like gender balance inside of the market, or to have a next generation policy. And we want to monitor over the time, ex post, after the publication and entering in force of the law, if the policy is producing the effect expected and if the law is working well. So using AI and the Akoma Ntoso, we can monitor over the time the legislation and to combine these with the policy. Finally, the last use case is very innovative, is an experiment, less mature with respect to the other two, but we are now creating a mechanism for calculate a tentative index of unconstitutionality of the bill, because these tasks take a lot of energy inside of the parliament, of institutions, in order to check in the preliminary phase if the bill is consistent with the Constitution or with the decision of the Constitutional Court. I now present the first use case. The first use case, as I said, is based on a database of Akoma Ntoso, and we have transformed many legal resources, heterogeneous corpora from Europe legislation, Constitutional Court of Italy, Italian legislation, and the bill coming from the Chamber of Deputies, all in Akoma Ntoso. This is a fundamental pillar because heterogeneous documents coming from different legal sources find in Akoma Ntoso the common data model. And so we can make queries in consistent way. On the top of these multi-heterogeneous corpora in Akoma Ntoso, we have developed the API of a module of artificial intelligence that we can combine like a Lego, or inside of editors, or inside of a portal for improving legal drafting in the editor, or search and retrieval inside of the portal. The data set that we are now using is very impressive because you can see the figures. We have transformed in Akoma Ntoso about 30,000 of documents, very complex with annex and tables, and in multiple language. But the very important part is to foster the nodes of XML, the structure of the XML of the document inside of AI. This is a new approach that we have applied in our research. We navigate the nodes of XML, and we create the embedding not only a sentence, but all the structure of the document. So we navigate the article, we apply the vector transformation of the article, but following the paragraph, the list, and in case we found a citation to other legislation, we follow the link, and we retrieve also the content of the link and inject inside of the model. In such a way, we have a more structured knowledge base inside of the vector, and we can foster this information for capturing the structure and the citations. The second use case was conducted with the support of the European Commission, the DG Informatics. The goal is to extract from the legislative text some very relevant part of the discourse that is called the reporting requirements. The reporting requirement is a command usually addressed to the Commission to provide a report periodically to the Parliament in order to monitor the evolution of the legislation over the time according to the evolution of the society. And this is a part of a larger methodology called better regulation. And the goal is to extract automatically this valuable part of the legislative test in order to monitor over the time these reports and to check if the report are due and also the quality of the report. So the project is composed by different components. You can see there is an extraction of the legal text and the knowledge using artificial intelligence. And we model this extraction using an ontology called RRMV, that means reporting requirements, metadata vocabulary. The ontology is maintained by the European Commission, and we can transform this knowledge in RDF, and we can integrate this information directly inside of Akoma Ntoso. So when the law will change after 1 year, Akoma Ntoso detects the modification, but according to the knowledge extracted and linked inside of Akoma Ntoso, we can monitor also the policy. One important ingredient of the solution is the ontology. As I said before, we try to adapt the traditional AI approach with the neurosymbolic approach, so injecting also the semantic. And this is a fragment of the ontology for detecting the temporal parameters of these reports, because these reports are due usually with a given frequency, after 2 years, after 6 months, or you can see we have multiple temporal parameters over the time. So periodically, after or before a deadline, or linked with an event. So to detect these events and to connect each other permits to monitor the effect of the policy over the time and not to lose the effect of these reports. So using this ontology, we inject the ontology itself inside of the model of artificial intelligence. So the model artificial intelligence take this information for extracting from the text these entities, this information in a different shadows. This is a result that are quite promising. We compared the different LLM, and the Gemma was the best, especially for the extraction of the temporal parameters that are so relevant for understanding the evolution over the time. And the extraction of this information are modeled using the ontology, and we have created a knowledge graph of this information. So the knowledge extracted is represented in a visual way to the legal people in order to navigate through the nodes and the articles with a click, and so to understand the effects that one modification can produce on the reporting requirements. So you can see in green the article 54, and green means that I intend to modify this article, but because it's in green, it is an alert for the civil servant that inside of this article there is a reporting request. And so if there is intention to modify the content of this article, there is a side effect on the policy that should be monitored over the time. So the effect of this project is, first of all, to extract the knowledge. Secondly, is to make evident this knowledge to the decision maker, and after, to monitor the policy over the time. You can find all the results in the papers that you can see in my slides. If you are curious to see the details, you can download these papers. The third use case is, as I said, very innovative under experiment with the Chamber of Deputies of Italy. In Italy, during the 2024, the more or less, you can see 45% of the judgments were about the constitutional illegitimacy of the law. So this is a big waste of energy, let me say, to check and to verify if a bill is compliant with the Constitution and the judgment of the Constitutional Court. So the idea is to create an environment where the legal expert can check and can take a benefit with the integration of different sources and to discover something hidden inside of the complexity of the network of the norms. So we have used Italian legislation, the entering force information, the Constitutional Court of Italy, the abstract of a Constitutional Court drafted directly by the Constitutional Court judges, the rationale of the decision, the classification of the case law citations in positive or negative in support of the legal reasoning of the judge. And using all this information, we have created a mathematical model and index of similarity. We have compared article by article with the judgment, article by article with the abstract, the bill and the classifications of the citation. And finally, we have also taken consideration if the judge in the judgment use legislative references abrogated, the index is very sensitive also to this information. And clicking on a bill, we calculate the tentative index of unconstitutionality, but not limited to the index. We return all the list of the case law of the Constitutional Court linked with the bill and the index of similarity with the bill. So in such interface, at the end, when we'll be finished, we transform the mathematics index in a very nice colorated boxes, and so the end user can see immediately the pertinent and relevant judgments of the Constitutional Court linked with the bill. This is very interesting in any case, because in such a way also the legal expert can check directly the legal sources and to evaluate if it is relevant or not. Conclusion. In these use cases, I demonstrate that we use a solid methodology that has a foundation on Akoma Ntoso, that is a fundamental part of the quality of the data set for training the artificial intelligence. The second point of our methodology is to have as a guideline the rule of law by design. The autonomy, the transparency, explicability, and accountability are crucial inside of a parliament. So any result is supported by evidence, and the legal expert can check directly the legal sources without intermediation by the AI system in order to verify if the output is correct or not. We use for doing so hybrid AI, so we use legal XML, ontologies, embedding, and in the future also agentic AI. We experimented already agentic AI for redirect the queries to the correct databases, because we have multiple resources by Europe, by Italy, and by the Constitutional Court. So the agentic AI take the query from the end user, understand the scope and the goal, and split the complex goal in sub-goals and redirect the queries to the appropriate database of Akoma Ntoso. In all these, very important the user experience, and to return in a dialogue way the control to the end user. So it's fundamental to design the user interface. In my opinion, it's the future to design AI tools and human-computer interaction techniques together, because through this part, we can guarantee the human in the loop and human on the loop, and also the explicability. As I said before, also agentic AI are very promising, not for disintermediate the relationship between AI and human being, but for creating a dialogue, a reasoning, and have the approach not code first or word first, but to have a loop of cooperation between human being and artificial intelligence. Now, I would like to present you some demos that support the use cases that I have presented, and this is the first use case. As I said before, we have transformed 34,000 of documents in multilingual and multi-corpus in Akoma Ntoso, and we can ask in a very nice way to extract relevant information concerning a bill. So suppose that I would like to make a bill about the animal law, and I would like to understand if at the European level exists some definitions, legal definition already included in some part of the legislation. I click the keywords, or I take a fragment of my bill, and using the fragment of the bill, the system analyzes the European legislation, calculates the similarity of my fragment of query with the rest of the bill, and in case of link, you have also the partition where exactly you find the important and relevant information. Another query, privacy. You know that privacy is not a legal term strictly inside of the legislation. We're talking about data protection or other legal definition, but suppose that I use privacy. This is a very important, because you can see that the system works as similarity algorithm on the syntactic point of view, but also semantic point of view, and return me, for instance, this priority list. And if the priority list includes also a link, like in this case, we can navigate the link and to verify the correctness of the output. This is the first use case. Obviously, I can do the same also with the other collection, or mix all the collection using agentic AI. So I ask, I'm a judge, I'm an international judge, I need to retrieve everything concerning animal, give me all the resource in a given period of time, because I can also define the period of entering force that I'm interested to the case. So suppose a judge needed to decide a case of 2 years ago, I fix the clock of the research 2 years ago, and the system calculates the similarity according to the clock. So this is what we have done in support of the legal drafting. But also, I jump to the second case. So suppose this is a Laos. Laos is an editor developed by the European Commission. It is open source, and in the back it is work with Akoma Ntoso. So this document is in the back, in the code, serialized, annotated in Akoma Ntoso. And using this structure, I can show you that in case I'm drafting this reporting request, I open a box You can see also the previous box of search of definition, but I would like to show you the extraction. So suppose that I'm draft these reporting requests, and I say no, 2030 is not correct. I need to say 27, and every 4 years, and it's not 4, but is 3 years. And this is what is in line with my policy. But now, please save the instruction, and save it in Akoma Ntoso. Akoma Ntoso call a AI tool for extracting the knowledge of what I'm typing, and in a now very technical way, but because we need to test, return the fragment of ontology, and the ontology is injected directly inside of Akoma Ntoso in a unique XML file that is included all the knowledge. So in these, we can create a data set very relevant, and this is a basis for the AI, for future data analytics, for monitor the policy, because during the typing, I can extract the valuable part of the legal knowledge and return for future applications. The future application is this, to have a graph, and in case of modification, like in this case that this Article 10 was modified in 2019, my reporting request changed from 4 years to 3 years, and using this graph, I can monitor my policy over the time in a very precise way, and to check if the policy produces effect expected. You can see the ontology published in open source here. There is a task force. I'm part of this task force, and frequently we have a group for maintaining this ontology updated. So this is what we are doing, and this demonstrates the fact that it is possible to create also very nice interface, transparent, and with the principle to have a dialogue between artificial intelligence and human being. Thank you.
Thank you very much, Monica, for the presentation. I was taking a lot of notes here on my side. I took a note on 3 questions I'd like to bring to you, if you allow me. First, I'd like to ask you if you could explain a little bit better. I know it's your field. How do you see specifically with XML standards like Akoma Ntoso, for example, how can it support the semantic enrichment and the interoperability with large language models, for example, ChatGPT, Gemini, Claude? How do you see this integration, if you could explain a little bit better?
Okay, thank you for the question, very relevant. So you can find in the portal of Oasis all the documentation about Akoma Ntoso and the specifications of the standard, and there are many examples already in production, like Akoma Ntoso for UN, because the UN adopted Akoma Ntoso as an official document standard, and also AKN for EU, because all the institutions of Europe made the same, so adopted Akoma Ntoso as a standard. So for the specification, you can find many examples, and also UK use Akoma Ntoso, and also US GPO, so General Publication Office, use a dialect adaptation for US legislation of Akoma Ntoso, called USML. But apart of these, that you can find so many experiences. Also, the Italian Gazette is now available in an open data portal, very new, in Akoma Ntoso, and the Senate of Italy. How to integrate this knowledge inside of LLM? So we use definitely open source LLM or open weight LLM, because we believe that the Parliament need to maintain the control and to maintain also the transparency of the applications. And using this LLM, open LLM, you can modify a little bit the model, or we can download locally and to use a fine-tuning for train the LLM with Akoma Ntoso. So it is possible to push the Akoma Ntoso as an input or require to LLM as an output of Akoma Ntoso, and using this knowledge inside of a pipeline.
Thank you very much, Monica. On the second question, you mentioned about the digitalization of 34,000 actually, documents that you did in one of the projects. So my question to you, what were the key technical challenges you faced and that you noticed that parliaments face when digitizing these old legal documents? Because as we understand, when we transition to XML, this is from D0 to the future. But when we have all of that passive, all of that, how can I say this, all of that backlog of maybe decades of documents that need to digitize as well. So what were the challenges that you faced and that you see that parliaments commonly face as well? And how did you face them?
Oh, thank you so much. So it's true. We don't start from the scratch. Many parliaments already have a great system digitalized and the proprietary standards or other standards. But in our experience, we produce a converter in the back, and starting from the legacy system, all the databases, we can transform also the back databases in Akoma Ntoso. So we are doing these for the WHO. We are doing for other institutions. We are doing for Albania parliaments, and starting from Word file or HTML or mix of these format with additional classic SQL database we can transform in Akoma Ntoso. This is for the legacy system. But definitely after this effort, we need to create a pipeline that since the beginning, using a such editor, transform step by step the relevant portion of the document in Akoma Ntoso for maintaining the chain updated and to have a benefit since the beginning. So to detect inconsistency between link or citation, renumbering, modification to not a correct article, amendment not consistent. All these benefits are possible only if you anticipate the transformation in Akoma Ntoso inside of a legislative process, not as an output of the legislative process. There is a topic. Each institution needs to decide the best balancing between effort to mark up and benefit. There is no magic ingredients. Each institution, according to the internal organization, according to the legal tradition, and also the legal process, should decide the best moment when to turn off from one standard to Akoma Ntoso in order to get the best of the benefit and minimize the time consuming.
Thank you, Monica. And my last question, you touched on this point during your response, which is the effort versus the gains, and also the legacy systems many parliaments still have, old frameworks from the 80s, the 90s, the early 2000s. And my point is, not necessarily all of them are able to replace the system or to phase out the system for a number of reasons. So my question to you is, well, not necessarily they would be able to transition right away to XML or using Akoma Ntoso, but they also want to experience the benefits of large language models. They want to use and to integrate all of these solutions that we're discussing to their legislative process. So my point to you is, what would be the minimum recommendations for then data standardization for them to be able to use securely and accurately these platforms integrated with legislative data?
So the point is that LLM is based only on probabilistic approach, and without the semantic of the structure of the legal discourse, the language discourse is quite difficult to get a very innovative output and a very innovative legal results. So LLM is good for very repetitive task, very tradition with a regular trend, because it's based on statistic and probabilistic approach. But if you need to check a new legislation, a new topic, completely innovative for the society, you need definitely to inject semantics. And because law in Parliament has this goal to be innovative, it's not a task like in the government. It is an application of law in a repetitive case law. In the Parliament, the innovative part is very relevant. So to prepare everything in well annotated way, it's maybe a matter of the quality of the data for obtaining good output at the end. It's different for the government. The government or the municipalities, the public administration, take the law and apply to case. And there is such a regularity sometimes of many cases equal each other. For the Parliament, it's not. It's different. And we are working also to create a dashboard for showing the similarity between amendments. Can you imagine to have 18,000 of amendments? Is not is a reality in Italy. When we have the budget law, the minority party produce automatically with LLM amendments. Many of them are no sense, but is a part of a democracy. So, but on the other hand, we need to have tools to minimize the effort of the civil servant to manage 18,000 of amendments. So to have a dashboard for classifying these amendments in not good at all, not make sense at all, or make sense but repeated 10,000 each other, is very relevant tool. But for do so, you need a Akoma Ntoso in the back, because amendment means to understand the destination where the amendment should be applied, not only the fragment of the text.